Cisco Certified Network Associate Day 29. Welcome back everybody, I'm Imran Rafai, your trainer for this entire series. Today we're going to learn about PAT and NAT, and this is a very important topic, and a topic that has in fact saved the internet as we know. Right, so without wasting much time, let's get straight into today's class. And before we go ahead, like always, we're going to put in our social media contacts through which you can contact us. And some people have asked me for my email address. I have in many of my videos I've said it out, but here I have listed it. So it is imran.rafai@nwking.org. Right, you can write it to me. I try my best to reply, but I wouldn't promise that all the emails would be replied, especially emails that I think answers for which are available. So if you watch my videos, you would get, like, I have a lot of people who write into me asking about IP addresses. What they do is they just watch the first video and then email me. So I would suggest that you watch all the videos and then come back to me with questions, because most of your questions are answered in my videos, right? So this is, like I said, this is day 29. Day 29, I think it is the 31st video, right? So watch the videos. I'm sure most of your questions would be answered. If not, of course, write to me. And I see a lot of people are helping on YouTube comments, so if you have anything, you can comment on the video. And I'm sure there are very good people around who love helping, so you would get your questions answered. And if I see that some of the questions are not answered, and if it is an important question, I will definitely jump in and answer those questions as well, right? So what are we going to look at in today's video? We're going to look at three things. We will do a recap. We have already done private IP and public IP, so we do a recap of what public IP is and private IP, right? And then we will look at what a NAT or PAT is, and then of course we will look at the configuration for each of those things, right? Private IP. Right, so we know there are three classes of IP addresses, right? There is class A, class B, and class C. And private IP in class A had this range of 10.0.0.0 to 10.255.255.255, right? So this whole 10 range, right? Anything that starts with 10, this is in the private range. And the public range for class A is 1.0.0 till 9, and then 11 to 126, right? And then we had a class B, right? Class B, this range in class B, 172.16.0.0 to 172.31. 255. So if you look at this, this is a slash 12, I think. Yes, it's a slash 12, and this is a slash 8, and this is a slash 16, right? So it's slash 16, 192.168.0.0 to 192.168.25, 255, right? So these are the private range, and these are the public range in class A, class B, and class C. Now, what is private IP? You know, we have discussed this many times. If you don't know, you can go back to our IP address videos, and I have mentioned. But just to say briefly, when we had IP routers, right? So we had, just to save IP addresses, we had a concept of private IP addresses, right? And these IP addresses, when they went to the internet, they got converted to a public IP address, right? Now, if I do IP config minus a Windows machine, when I do IP config, my computer, my wireless LAN adapter, has an IP address 192.168.1.103, right? This is my private IP address. If I go to the internet and go to Google and I type what is my IP, it tells me my IP is 78.100.196.163, right? This is an IP address. This is a public IP address. So for all purposes, my computer is visible to the internet with this IP address. So this is the public IP address of my computer, and 192.168.1.103, that is the private IP address of my computer, right? So Private IP is generally used for your private communication. You cannot go to the internet with that IP address. So if you have to go to the internet, you need to have a public IP address. Now, the reason why and the history of that, I would suggest you go back to our old videos, and I think day 3 or day 4 we have discussed this. So please feel free to go back and watch those videos again. So what is a NAT? NAT is nothing but network address translation. There are 3 types of NAT. There is static NAT, dynamic NAT, and NAT Overload, which is also known as PAT. NAT is a short form for network address translation, and PAT is port address translation. Now, what are these? We will be looking at it very soon in our next slides. But there are 4 topics or 4 terms that you need to familiarize with when you're dealing with NAT. That is inside local. Inside local is the IP address. Like I said, NAT is what is NAT? NAT is, if you remember, NAT is a form of translation of your private IP, right, which cannot go to the internet, to a public IP, right? Because if the private IP goes to the internet and the receiving device, if it receives a packet with source IP address as a private IP address, it will drop that packet. So that cannot happen. So we need to give it a public IP if it has to go to the internet, right? When the translation happens, there are 4 terms. Inside local. Inside local is the IP address of this host. So let's say this host, this has a private IP address. So inside local is the private IP address. So inside is the source, inside local. So before translation, what is the inside IP address? That is of this device host and this private IP, let's say 192.168.1.10. So that is the inside local address. Inside global, so if this packet goes to the internet, what is that globally known as? So let's say this is 200.124.22.10, right? So inside global is going to be this address. So inside local is the private IP address. Inside global is the public IP address which it is going to be translated to. Outside local, the outside, it's referring to the destination. So just remember, inside is referring to source and outside is referring to the destination. So outside local, so before translation, what is IP address that is of the destination device? It's the same thing. So let's say this is 200.124.22.100, right? So the outside local is the same thing because that's where it wants to go before translation. Outside global is after translation. Even after translation, the destination does not change. The destination is going to be the same thing. So from almost all scenarios, your outside local and outside global is going to be the same, right? Inside local is going to be the private IP address, and inside global is going to be the address to which it is going to be translated to, right? So let's look at static NAT. What is static NAT? Static NAT is one-to-one NATing. That means to say, if there are 3 devices in your local network, and if these 3 devices need to go to the internet, we need to have 3 public IP addresses. So 192.168.1.10, we will statically map it to this IP address. 1.11 we have statically mapped to 22.3, and 1.100 we statically map it to 22.3. So this is going to be a 1:1 map. So if there are 100 devices, they need to have 100 static global IP addresses or public IP addresses. So if you look at the reason why NAT came into being, like we discussed, NAT came into being to save the internet because we were running out of public IP addresses, and we came in with this concept of private IP addresses and made use of NAT, where you could have multiple companies and multiple networks can have the same private IP address, but when it goes to the internet, NAT makes use of a translation mechanism where it translates those source IP addresses to a public IP address, and it sends those data into the internet, right? So that's the reason. So you might say, okay, Imran, so you said NAT is going to save the internet, but in this case it's not going to save the internet, because if I have 100 devices in my network, we need to have 100 public IP addresses. You're right, absolutely right. But this is what static NAT is. You need to have 100 devices. There are some benefits, like for instance, this is a two-way NAT, bidirectional. That means, let's say in this case, this is a server. Now, server, if it has to be accessed from the internet, 192.168.1.100, it cannot be accessed. So let's say if I have a device here and it can't address, destination cannot be this IP address. So what I will do is I will give an IP address, a static IP address, as let's say .3 in this case, and this device for all practical purposes will be communicating to this IP address, 200.124.22.3. If static NAT is configured, that anything that is coming to .3, right, like I said, this is bidirectional. So if this device 1.100 wants to go to the internet, it will go as 200.124.22.3. If there is any traffic coming into 22.3, it will automatically send that to .100, right? So this is bidirectional. So from outside you can access inside using static NAT. But downfall is you need to have 1:1. That means only one IP address can be mapped to one public IP address, right? Next, let's look at dynamic NAT. Now, dynamic NAT is very similar, but the only difference is you're not statically mapping. So let's say we have these two IP addresses. So we have these two public IP addresses. I meant to do this. Okay, anyway. We have these two public IP addresses and we have 3 devices. Now when this device wants to, the first device, whichever, let's say this device comes in first, .11, so it gets mapped to the first available IP address. Second, let's say 192.168.1.100 comes in, wants to go to the internet, so the router does this, so it assigns 200.124.22.2 to this device. Now when our third device, 192.168.1.10 wants to go to the internet, it will not have an IP address to assign it and it will drop that packet. That means to say now we can have hundreds of private hosts, but because we have only 2 public IP addresses, any of these devices, we are not statically mapping. That means any of these devices can access the internet, but only 2 at a time. So anytime you can have 2 devices that go out to the internet, right? So this device goes to the internet, it gets the first IP address, then second it gets. So until the translation works, until the translation times out, so there is a translation timeout. I think on a physical device the translation is set to 24 hours on Cisco devices. We can change those translation timeout values. We can make it 1 minute, 2 minutes, 3 minutes, 10 minutes, whatever we want. So if the third device comes in and if the translation times out, automatically this will go back to the pool, right? And if the third device comes and if there is a free IP address available, then yes, it will let it go through and that will be assigned. So there is a translation table that it maintains, right? Dynamically it keeps updating the table. So if the translation is still valid, timeout is not done, that translation is valid, right? That's what dynamic NAT is. And then comes our favorite NAT, or what we call as PAT. This is also known as Nat Overload, right? Nat Overload is nothing but PAT. PAT is port address translation. So this is the most common form of NAT. So in your home computers, like I said, home device, home network, you connect your iPad, your phone, your computer, everything is connected to your router, and then that router has only one public IP address, right? And this is what lets your internet, your home network, and mostly almost all the network, and this is in fact what really NAT is meant to be, right? This is what saved the internet or the IP version 4 internet. So what happens in this case is you have one public IP address, 200.124.22.1, and you could have hundreds, like maybe 100 internal hosts, and all of these hosts would access the internet with this one public IP address, 200.124.22.1. What changes? What changes is the port number. So if you remember in our discussion of transport layers, transport layer had port numbers, right? So there is a source port number which is a random number. So if this computer wants to communicate with a host on the internet, so let's assume there is a host on the internet, and this is let's say disk 200.124. I mean, let's make it easy, 22.10, right? If this device, let's say 1.11, wants to communicate with 200.124.22.10, it creates a random source port, right? Let's say 51772, right? So let's take this into consideration, right? So it created a random port of 51772. It comes to this traffic destination IP address is 200.124.22.10, and destination port number, it's let's say 80, like it's going to the web server of this device. When it comes to this router, the router says, I see you want to go to the internet, so what I'm going to do, I'm going to translate you. So from now onwards, your source IP address is going to be 200.124.22.1. This is something we can assign. We can tell what IP address we need to use to go into the internet, and we tell that your new source port number is 23556. This packet goes to this device. Now this device, as we know how the internet works, it will send a reply back to destination of 200.124.22.1, which is nothing but global for everybody, but then it is going to destination port number is going to be 23556. And when it comes here, this device has a translation table, right? This is the translation table that it says, okay, you're coming to 23556. 23556 is nothing but a translation that I made for 192.168 1.11 for a port number 51772. So it takes those information, updates this destination's IP address and destination port numbers, and it sends onto the network, which will definitely get delivered to this device, and our communication works, right? Now this can happen, you can have at the same time, you can have multiple devices, maybe even 100 devices communicating over this one IP address, multiple ports, and that is why this is the most popular form of NAT, which is nothing but port address translation, or PAT. Let's look at the configuration of static NAT. So static NAT, first thing, for all NAT, this is common for all NAT, we need to designate inside and outside interface. So let's say this is the router, and we want the translation to happen going from in to out, right? From your inside network to the outside network. So that means this is the inside network, inside interface, and this is the outside interface. So how do we designate that? We just go into that particular interface and we give the IP address, obviously one IP address, whatever that IP address that you give, and you have this command which says IP NAT, and you give the keyword inside, which tells that this is the inside part of your network. And similarly, we have IP NAT outside, which says outside. So always translation happens from inside to outside, right? I mean, like I said, static NAT is bidirectional, so static NAT will happen the other way as well. So you will have outside to inside as well for static, but not for all the other. For, let's say, dynamic NAT and for PAT, outside to inside will not happen. Of course, if there's a translation table, of course it will reply, but then you cannot initiate a translation from outside to inside. But with static NAT, you can initiate the translation from either side, right? So that's how you designate. Then you configure static NAT. So static NAT, like we said, if there are 10 devices, then we need to have 10 static assignments. So in this case, we have 3. So we're saying IP NAT, we're telling from inside, the source is static, right? Source is static, so it is 192.168.1.10. We're telling 192.168.1.10 should be translated to 200.124.22.1. That is your first translation. Similarly, we're telling 1.11 should go to 22.2. Second translation, 1.100 should go to 22.3. That's your third translation. So we are translating every IP address, right? You're manually, statically configuring those. That's why it's called static NAT. Right, so what I've done is I have configured this same thing with packet tracer. I've given this 192.168 1.100, as you can see. This is 1.10 and this is 1.11. This device, router 0, I have given IP address 192.168.1.1 and 200.124.22.1 in the outside interface. What I've done is, instead of having a cloud or the internet, I have put a router here. Right, I've set this IP address 200.124.22.10, and what I've done is, in fact, I am going to do it now. I'm going to say debug IP Icmp. Right, what happens is I'm going to Icmp debugging is on now. That means anytime there is an IP ping that comes to this device, it will start showing those debug messages here. So we will know that packets are reaching here. Right. Now what I'm going to do is let's configure the device. So enable configure terminal interface G0/0. Okay, and I'm going to say this is IP NAT inside, right? And I'm going to go to G0/1 and I'm going to say this is IP NAT outside. Right, so now we have designated the inside and outside interface for this device. Now I'm gonna configure manual IP addresses. So let's go back to that table. Alright, I'm gonna configure this static NAT. So IP NAT inside source static, and I'm going to give this IP address 192.168.1.10. You please translate that to 200.124.22.1. Hit enter. Similarly, 1.11, I need it to go to 20.2, and I want this to go to the server 1.100 to go to 20.22.3, right? So now I've done this. Now what we'll do is we will go back. Okay, now I want to ping from each of these devices to this device, and I want to see what is the IP address it is coming in from, right? So I'm going to keep this open here because it's going to give me the debug messages, and I'm going to go to a command prompt here. Okay, and I'm going to, so let's do this. Alright, so what I'm going to do now is I'm going to ping, so ping 200.124 dot what is that IP address? Forgotten. Show IP interface brief. Alright, so I'm going to ping this IP address 200.124.22.10, right? And it is replying. So where is it replying to? It's replying to 200.124.22.1. So it's replying to 22.1. That means this IP address 192.168.1.1, show IP config. So you will see that 192.168.1.10, right? 1.10 has been translated to 200.124.22.1. I'm going to ping from here. Ping 200.124.22.10. Where is it? It's getting converted to what? It's getting translated to 200.124.22.2, right? So this computer, right, is getting translated to this IP address, and we'll try from the server ping 200.124.22.10, and we can see that this is in fact getting translated to 200.124.22.3, right? So this is absolutely perfect. This is exactly what we wanted. Translation is happening. That means when any of this communication hits this device, according to what translations that we have configured, static NAT, it converts or translates those IP address to an IP address that we have given from the public domain, and that's what the IP address that the traffic is hitting this router, right? Again, another thing is what we can do, how we can verify the translation. We can say show IP Nat Translations. It will show all the translation that's happening. So at the moment you can see that 222.3. So inside global, if you remember, inside global, that is the IP address of your device from before translation, but the public global IP address. So globally this device is known as 200.124.22.3. Inside it is 192.168.1.100, and outside local 200.124.22.10 and 200.124.22.10. These are the outside local and outside global addresses. Like I said, they will be the same because we're not translating the destination IP addresses. So this is how you see the translations, and normally on a regular device this translation stays for almost 24 hours, but in Packet Tracer it quickly times out. It's good because we are learning, and this is we can look at things. So now if I initiate a traffic from outside, this is outside, and if I initiate a traffic to ping 200.124.22.3, it's traffic coming from outside to inside, and you see that the traffic worked. So if you go back here and we look at translations, you see that translation has been successful. That means it is getting translated. Even like if you saw the translation had timed out, now whatever translation started, this initiation happened from outside. So we started this translation from outside interface, and this happens only with static NAT, right? So this is what static NAT is. Now what we'll do is we'll look at dynamic NAT. So what is dynamic NAT? Dynamic NAT, on the other hand, is slightly different from static NAT, like we discussed, where we can have, let's say, 2 public IP addresses, and we could have maybe 10 or 20 or 100 private devices, private hosts, but at a time only 2 devices can go to the internet because we only have 2 public IP. So it's something similar to static, but it's not statically, you're not mapping public and private IP addresses. It is there for dynamically creating those translations. We'll look at it. So what is different in your configuration level? Of course, we have to designate the inside and outside, so we do the same thing what we did previously. Then what we do is we make use of access lists. Now this is another use of access list. So what access list does is, access list is used to identify the traffic that we want to translate. Let's say we want only some devices that we want to translate, so we can make use of access list and do an access list permit, right? We're not permitting or denying traffic here, but we're telling that these are the interesting traffic. So that's another term, interesting traffic. Interesting traffic is the traffic that we want to translate, right? So interesting traffic is a term that is used for a lot of things. Even if you're looking at VPNs, interesting traffic is the traffic that we want to let through a VPN tunnel. So interesting traffic is a term that would be very commonly used in NAT or VPN, right? So we make use of an access list to identify the interesting traffic, right? In this case, we are identifying the entire network of 192.168.1.0/24 by we making use of a wildcard mask, and we know what a wildcard mask is, right? If we go back to our last video, if you want to know more about wildcard mask. Then we create an IP Nat Pool, right? We make use of this command IP Nat Pool, and we give a name, whatever name you want, and then we give the pool of IP address. In this case it's 200.124.22.1 to 200.124.22.2. that means we're only giving 2 IP addresses, and we give a net mask. This is a keyword. You have to give the word net mask and then give the wildcard mask, the subnet mask, because it's net mask of 255.255.255.252, right? Depends on your case. You can make any network. So if you want 254 IP address in the pool, then you would be giving 255.255.255.0, right? So that's up to you to identify, but that's something you have to identify, right? Otherwise you will have it all wrong. So make sure that you give the correct net mask here, and then we make use of this command to actually do the natting. We say IP Nat inside, and so till here it's a common thing. Then we set static in our previous thing, but here we are saying the source IP address is going to be identified using a list, an access list 1, right? And you translate it to, in the previous case it was again a static IP address, but here we are telling translate it to a dynamic pool. We're saying we're giving the keyword pool, and we're telling which pool, right? So before we give this command IP Nat inside, we need to create access list and a NAT pool, and only then this command will work, because this is what we're making use of, this access list and this pool, right? So now anytime any traffic from this range, right, that is 254 hosts, wants to access the internet, only 2 devices will be able to go to the internet. The first device will take this IP address, the second device will take this IP address, the third device will have to wait until the NAT translation clears, and only then it will be able to access the internet. So these are the 4 steps. We do designate inside outside, then we identify interesting traffic using access list, then we create a NAT pool, and then we configure. So let's go to packet tracer and look at this. So what we do is, let's delete the static NAT. So this is a static NAT, no, and a no. So I have deleted the 3 static NATs that we had configured. Now let's create an ACL. We have done the first part, designating inside and outside, we have done. Now let's do access list. So we say access list 1, right, and then we say permit, and we match the whole network. So we say 192.168.1.0, and then we give a wildcard mask, which is 0.0.0.255, right? So we've done the access list. Now we'll create a NAT pool. So IP Nat pool, right, and we give a word NW king, and then we're giving the IP address. So we're telling 200.124.22.1 to the next IP address. The end IP address is 200.124.22.2, and we give net mask, and the net mask is 255.255.255.252. Now we say IP Nat inside source. Now the source is a list this time, so we say source list. Which list? Access list. Access list we gave number 1, so source list 1. Then we tell pool or interface, but we're going to say pool because we need to have more than one IP address. If you say interface, it's just going to take that interface physical IP address. If it's pool, you can give any IP address. In this case, of course, it's going to be 200.124.22.1 and 22.2, but this pool can be any IP address. It need not be the IP address that is configured to the interface. In this case, this IP address is configured on the interface, but that's not the case. You can have any IP address that's not even configured to the interface, right? It's just that you have to make sure your routing tables are updated so that any of those IP addresses in your pool should be directed to this device, otherwise you'll not be able to get a reverse traffic, right? So we're going to give a pool, and what's the pool's name? NW king, and we hit enter. This overload is used for PAT. We will be using it soon, but at the moment we're going to hit enter, and this would enable Dynamic Nat. So now let's do this. Let's go back here. Let's keep our debug window open. Let us open the first device. We'll make sure there's no IP Nat translations. So we look at this, we see there is no translation at the moment. So I'm going to go first device, second device, and the third device. So okay, so now what I'm going to do is I'm going to ping. So ping, the same thing. Now you see that the ping is working. I can see the destination is coming from 200.124.22.1, which is what we're expecting it to come from. The second device, I'm going to use the server, right? I'm going to do the same thing, and you can see that the server has got the IP address 200.124.22.2, right? Now let's use PC1. Let's ping from here and see what happens. You see that the ping is getting failed because these two translations, we only have two IP addresses, and PC0 and server has already used these IP addresses. We can verify that from here. We can see that 22.1 and 22.2 is being used. So until this clears the translation, until the translation times out, it will not work. So we can see that translation is failing one by one. So all the translation for .1 has successfully cleared. Now if I use this this device, the last time it failed, but now if you see, this is working and it is coming from 22.1 because 22.1 was cleared by this device. How do we now, if you go look at the translation, you have this translation. How do we clear that? We say clear IP Nat Translation star. This is the command to clear your NAT translations. So now if you look at it, there's no translation. Another command to look at is show IP Nat Statistics, right? Statistic is a very good thing. It will give you all the statistics. It says total translations are 0 because we just cleared. Outside interface is this, inside interface is this. There are 129 hits and 142 misses, right? Misses happened because we did not have translations, or you had ARP failures, all those things, right? Expired translation 108. Access list is this. Access list is 1. Pool is networking. Pool, it gives you pool information, right? So all this information are given by this command IP Nat Statistics, right? So that is dynamic natting. Now there's one more kind of natting, which is our favorite, which is PAT. So we're going to look at that. Exactly the same thing. First step is designate inside and outside, like how we did earlier. Then we identify the interesting traffic. Then we create a NAT pool. In PAT, we could create a NAT pool where we can have more than one IP address for natting, but it's of no use because every time the first IP address would only be used. So we could create pool, but we don't need to create pool, right? And we of course configure dynamic NAT. The difference from dynamic NAT and PAT, so this should not dynamic NAT, this should be PAT, my mistake. But the difference between dynamic NAT and PAT is only this keyword. So if you look at what we did earlier in dynamic NAT and in PAT, the only difference is this keyword overload when we finish configuring. So IP NAT inside source list pool and give the keyword overload, and it automatically becomes PAT. And another thing is, you give a pool. You could give a pool of 22.1 and 22.2, but it's of no use. So you make use of this pool, but we give the same IP address 22.1 and then 22.1 with the net mask of 255. Instead of giving this whole thing, because we could make it easy, we could, instead of giving this whole pool thing, we could say source interface, right? If you remember, I'll show you there's something called interface, and we can give this interface G0/1. Automatically this IP address, which is configured physical IP address, would be used as your translation IP address, and it will be used to go to the internet. Of course, you could use pool and you can give a totally different IP address, not the one that is configured to the physical interface. That will also work, right? If you use an IP address that's not configured to your physical device, it's up to you to make sure that all the devices, so let's say you have another router here and router here, all these devices should be able to route those traffic to this device, right? So that's something that you have to make sure you do that. Otherwise, this is where NAT fails, where you don't have routes to come back, right? You create you create a NAT translation, right? You configure NAT, but the NAT does not come back because those devices on the internet cannot have route back to your devices, right? So it's up to you, depending on what is the IP address that you're using, it's up to you to make sure that that IP address is routable in your network. All right. So let's look at it from packet tracer. Right. I'm gonna go delete dynamic NAT, right? So, and I'm also going to delete the pool, IP NAT pool. We see that. What we could do is we could create a pool, right? We can have this whole pool as 2.1, and this is going to be 255. So we have a pool. Okay, let me do this. I'm going to say no to pool, but I'm going to give a IP address that's not the IP address of the physical device. Physical device is .1, we'll give .2. In our case it'll work because it's a local network, so it will work. Now let's configure PAT. So it's IP NAT pool, IP NAT, okay, forget this, we'll type it. So IP NAT inside source. Source is a list is 1, pool is NW king, and we give this word overload, and this becomes PAT, right? So exactly the same thing. We will verify, we'll go back to our devices, so we say server PC1 PC0. I'm going to do the same thing, ping, and you see that it is coming from 200.124.22.2, which is what we expected it to come from. It's coming from the exact same IP address, 200.22.2. It is coming from the exact same IP address, 22.2. Now if you go back to our translation tables, let's look at the translation, what's happening. And you see that the translation is absolutely happening, and it is happening with port numbers. So we have port numbers which is translating, and all the devices, you can see that 1.11, 1.10 and 1.100, all of them are going to 22.2, 22.2, 22.2, and PAT is absolutely perfectly working. So we can go look at this. We can look at the statistics, and it tells you the statistics. You have total 12 translations. What is the pool? What is this? We can also look at, like I said, we will not make use of pool this time. We'll try something else. So IP NAT inside source list 1, and then this command interface gigabit Ethernet 0/1. So I'm giving the outside interface, and I'm going to say overload. Right now, what happens if I ping from here? If I ping from here, you can see that it's coming from the IP address of the physical interface, 200.124.22.1. Right? So that's an easier command. So if you don't want to do the pool, well, this is exactly what happens in most of our home routers. It just uses the interface IP address. So whatever that IP address is, your public IP address of your interface, that is what is being used to translate your private host to the public network. Right. This is an important topic. There are so many things that we discussed today. So we need practice. So you have to practice. Go register with the Network Academy. Right, and then I think you can download Packet Tracer if you don't have Packet Tracer. Please download, start practicing on Packet Tracer, because once you don't start practicing, these concepts are going to be very, very confusing, and it's going to be very, very difficult. So once you start practicing, then it becomes easy. And we are reaching the end of ICND1, so I think what I will do in the next video is we'll look at our latest syllabus. We'll look at what are the topics that we have covered and what are the topics we haven't covered, and we will do that one final video, and I think we should be done for ICND1. And you can start watching the videos few more times, and of course practice, and then you can go do your ICND1 exams. So maybe in the next video, the video after, we will also show how to go register for ICND1 exams and how to take the exams, right? So thank you so much for watching. Stay tuned, and we will be back very, very soon.